In the fall of 2017, astronomers at a Hawaiian observatory made a discovery that would quietly rewrite the boundaries of everything we thought we knew about our corner of the universe. They had spotted something moving through our solar system. At first glance, it looked like a comet. No coma appeared around it, though, none of the characteristic halo of gas and dust that forms when solar heat begins to cook an icy body. So they reconsidered. Maybe an asteroid. But asteroids follow rules, and this object wasn't following any of them. They named it Oumuamua, a Hawaiian word meaning the first distant messenger. Scout, in short. The name turned out to be more accurate than anyone anticipated. I'm Michael Alex, and you're watching Vortex. Today we're going somewhere most telescopes have never pointed, and most minds have never had to go. 3 objects. 3 arrivals. And a universe that is starting to look a lot less empty than we thought. The first indication that something was deeply strange was its speed. Every object in our solar system, every planet, every comet, every asteroid, is gravitationally tethered to the Sun. There is a ceiling to how fast something can move before the Sun can no longer hold it. From Earth's distance, that threshold is about 42 kilometers per second. When instruments locked onto Oumuamua, it was traveling at 87. Nearly twice the escape velocity. It wasn't orbiting our Sun. It was passing through, a traveler from another star system entirely, the first interstellar object ever detected by human beings. But the speed was just the opening act. Oumuamua flew closer to the Sun than Mercury before curving back outward. A close gravitational pass like that should have slowed the object down. Physics is very clear on this. Instead, as it moved away from the Sun, it accelerated. Something was pushing it. Some internal force was providing thrust that our instruments couldn't directly observe, because there was no visible exhaust, no outgassing, no trail of any kind. That eliminates the possibility of it being a simple rock. Definitively. Rocks don't have thrusters. Then there was its shape. As Oumuamua tumbled through space, the amount of sunlight it reflected oscillated dramatically every 7 hours, cycling from bright to dim in a rhythm that implied an extreme geometry. Either long and narrow like a cigar, or wide and flat like a disc. Either way, unlike any natural object we had encountered before. And it was highly reflective, far more so than ordinary stone, suggesting a surface composition we couldn't identify at a glance. By the time we understood what we were looking at, Oumuamua was already leaving. No rocket in existence could catch it. The first messenger from the stars arrived, made its pass, and disappeared, leaving behind far more questions than answers. 2 years after Oumuamua vanished into the interstellar dark, the sky produced a second surprise. In 2019, an amateur astronomer named Comet Borisov, working from his private observatory in Crimea, caught an object inbound on a hyperbolic trajectory, moving too fast, coming from too far, to be anything native to our solar system. It was the second interstellar object ever detected, and it was given his name, Comet Borisov. Where Oumuamua had been a riddle wrapped in anomalies, Borisov was almost refreshingly ordinary. It looked exactly like a comet, complete with a proper coma and a tail. Its chemical makeup matched the comets in our own solar system with striking similarity. Its behavior was predictable. Its trajectory was clean. If you had taken Borisov, stripped away its interstellar origin, and placed it alongside the other comets looping through our inner solar system, it would have fit right in. An unremarkable comet, by all measures, except for where it came from. This was actually significant. Borisov confirmed something scientists had theorized but never proven, that objects from other star systems travel through ours with some regularity. The galaxy, it turns out, is less isolated than we imagined. Material gets ejected from distant systems through collisions, gravitational interactions, and orbital chaos, and some of it eventually drifts into our neighborhood. We simply hadn't had the instruments, or the luck, to catch any of it before 2017. Borisov also threw Oumuamua into sharper relief. Here was a perfectly normal interstellar object behaving in perfectly normal ways, which meant Oumuamua's strangeness wasn't some artifact of our inexperience with interstellar visitors. It was genuinely, specifically, stubbornly weird. A curious pattern was also emerging. For the entirety of recorded human history, thousands of years of stargazing, decades of modern astronomy, we had detected exactly 0 interstellar objects. Then, within 24 months, we had 2. The pace was surprising. Whether it reflected improved detection technology, a statistical cluster, or something else entirely, no one could say for certain. But it raised an obvious question: would there be more? The answer came in 2025, when an automated sky survey called ATLAS, the Asteroid Terrestrial Impact Last Alert System, flagged something incoming. Something bigger than either of its predecessors. Something faster. And this time, we spotted it early enough to watch it arrive. On July 1, 2025, ATLAS detected an object at a distance of 4.5 astronomical units from the Sun, roughly as far out as Jupiter. It was designated 3I Atlas, the third interstellar object ever identified. And for the first time in history, we had caught one on its inbound journey. We weren't studying its departure. We were watching it approach. The numbers surrounding 3I Atlas are extraordinary. Its coma, the cloud of gas and dust surrounding the nucleus, spans approximately 20 kilometers in diameter. The solid core inside may be as large as 11 kilometers across. Compare that to Oumuamua, which measured only a few hundred meters at its longest, or Borisov, estimated at a kilometer or 2. These interstellar visitors appear to be getting larger with each encounter. 3I Atlas is potentially 10 times the mass of Oumuamua and 5 times the size of Borisov. Its speed surpasses both predecessors. And its direction of origin is entirely different, not from the region of Vega, like Oumuamua, nor from Cassiopeia, like Borisov, but from a part of the galaxy astronomers associate with what's called the thick disk. To understand why that matters, a brief detour into galactic geography is useful. Our Milky Way, viewed from the side, resembles a layered structure. At the center is a dense bulge. Surrounding it is the thin disk, a flat, star-rich plain where our Sun resides and where active star formation continues. Above and below that lies the thick disk, a sparser, more diffuse region populated by much older stars. Objects from the thick disk formed in the galaxy's early epochs, billions of years before Earth existed. The chemical environment there was different. The physics of star formation were still being established. 3I Atlas may have originated in that ancient region. On the high end of estimates, it could be more than 7 billion years old, predating our solar system by over 2 billion years. This object was already ancient when the Earth was still a cloud of gas and rock waiting to collapse into a planet. It has been traveling ever since. 3I Atlas's trajectory carries it through the solar system at an angle, allowing it to pass relatively close to Mars, Venus, and Jupiter in sequence. Earth will be on the opposite side of the Sun during its closest approach, meaning our telescopes will lose sight of it in October and won't recover the view until December, by which point it will be outbound. The window to study it, though wider than anything Oumuamua offered, is still finite. And the scientific community is moving quickly. 3 objects. 3 arrivals in under a decade, after a complete absence throughout all of recorded human history. Each one larger than the last. Each one from a different direction. Each one carrying a different kind of mystery. The most grounded explanation for the uptick in detections is technological. Our sky surveys have become vastly more sensitive in recent years. Atlas and systems like it are scanning broader areas of sky, more frequently, with greater precision than anything that existed even 20 years ago. It's entirely possible that interstellar objects have always been passing through our solar system at roughly this rate, and we simply lack the tools to notice them. In that reading, the 3 detections aren't a cosmic anomaly, they're a calibration. We're finally seeing what was always there. But there are other possibilities worth holding. The current leading natural explanation for Oumuamua's strange acceleration involves nitrogen ice, the same material that blankets Pluto's surface. Frozen nitrogen is highly reflective, which would account for Oumuamua's unusual brightness. And when nitrogen ice sublimates under solar heat, it converts directly from solid to invisible gas, producing thrust with no visible trail. A fragment of a shattered nitrogen ice dwarf planet, ejected from a distant system and flung across millions of years of interstellar space, would behave almost exactly as Oumuamua did. Almost the artificial hypothesis has never been formally ruled out. Several credentialed astronomers have published serious work exploring it. Not as science fiction, but as a falsifiable proposition. Could Oumuamua have been a manufactured probe from a distant civilization? We have no evidence that it was. We also have no evidence that conclusively proves it wasn't. Science, at its most rigorous, has to hold that possibility open until the evidence closes it. 3i Atlas gives us the best opportunity yet to close some of these open questions. Spacecraft already operating in the outer solar system, including the Juno probe orbiting Jupiter, exist within potential range of an intercept. A rendezvous mission is unlikely but not impossible. And even without one, months of telescopic observation will yield spectroscopic data, refined size estimates, and compositional clues that could tell us where exactly this object came from and what it's made of. What the 3 visitors share is a kind of insistence. They arrived without invitation, behaved in ways that demanded explanation, and left us with frameworks that no longer quite fit the universe we thought we understood. The galaxy, it turns out, is not a collection of isolated systems drifting in silence. It is porous. Material moves through it. Ancient things travel across it. And occasionally, one of them finds its way to us, a message from somewhere unimaginably far away, written in physics and light, waiting for us to learn how to read it. If this video made space feel a little bigger, and a little stranger, than it did before, hit that like button. It sounds simple, but it's genuinely how the algorithm decides whether to show this to the next person who would love it just as much as you did. Science content doesn't always get the reach it deserves, and every like is basically you telling YouTube, send this to someone else who needs to see it. And if you want to be that person next time, the one who finds out first, subscribe to Vortex. Every video we make is built for people who look up and actually want to know what's out there. We're just getting started. We'll see you in the next one.